Hey guys, today you are going to be working with the properties of quadrilaterals that you learned yesterday. So right now it might be a good time to get out that graphic organizer that you made with yesterday's notes so that you can reference the properties of all the quadrilaterals that you learned. Okay, here's an example of solving using the properties of parallelograms. So the first thing that we need to know is what properties are going to be used to solve for A and solve for B and ultimately to find YZ in the measure of angle Z. So the first thing that I'm going to do when I start is I'm going to say, well, what properties do I need to know to solve this problem? So the properties of a parallelogram I need to know is that opposite sides are congruent. And also, consecutive angles are supplementary. Consecutive means right next to each other. So consecutive angles are supplementary. What does it mean to be supplementary? Hopefully you remember this from previous units, but supplementary means that it adds to 180. Okay, so what these two properties can do is tell me a lot on how to set up these actual problems. So if opposite sides are congruent, I'm going to add these two tick marks to show me that side WX is congruent to side ZY. So from there, if they're congruent, I can set these two expressions equal to each other to solve. My goal is to find YZ. So ultimately, I want to find the entire length of this bottom side of the parallelogram. Okay, so what I'm going to do is I'm going to take those two expressions, so 6a plus 10, and I'm going to set them equal to each other to 8a minus 4. Okay, from there you can solve. You just want to get your a's on one side and your numbers on another side. So minus 6a on both sides. I'm left with 10 equals 2a minus 4. I'm going to add 4 on both sides. So that would give me 14 equals 2a. And then the last thing is 2 and a are being multiplied to each other, so divide 2. That means that a is equal to 7. Now that's great, but that's not what it actually asked me to find. It wants me to find the side length of YZ. So I'm actually going to plug in that 7 into a, and then I'm substituting that value. I'm going to use my calculator, and I'll get 56 minus 4. So 52 is equal to YZ. Okay, so for this next one, I want to find the angle of measure of angle Z, excuse me. So these two angles right here, this angle and this angle, they're not congruent, they're actually supplementary. So what you have to do for this one is you have to take the two expressions, add them together, and set them equal to 180. Okay, once you want to do that, you want to get your like terms. So combining like terms, I have 9b and 18b are like terms. Okay, and then also 2 and negative 11 are like terms. So if you add 9b and 18, you'll get 27b. 2 and negative 11 is negative 9, or minus 9 equals 180. Last step, you're going to solve for b, so add 9 over. 27b equals 189. Divide by 27. That means that b also equals 7. Okay, but what we want to actually do is solve for z. So the measure of angle z is 9b plus 2. So I'm going to substitute in my value for b, so 9 times 7 plus 2, which is 63 plus 2. So the measure of angle z is 65 degrees. Okay, here's another example of a parallelogram, but this time we have different properties that we are working with. So think to yourself, what is FH? What is GE? Those are both diagonals of the parallelogram. So let's again think about what properties do I need to know in order to solve this parallelogram. And the big one here is that diagonals bisect. That means the two diagonals cut each other in half, so that this side, EJ, is congruent to JG, and further, FJ is congruent to J. So in order to find JG, what you want to do is notice that EJ and JG are congruent by that bisect. So I can take 3W and set it equal to W plus 8. I'm going to subtract W over, and I have 2W equals 8. Then dividing by 2, W equals 4. But we don't want W, we wanted to find JG. So JG equals W plus 8. And if I substitute my value for W, I'm going to go 4 plus 8 equals 12. So that means that JG equals 12. But not only do we know that JG equals 12, we also know that EJ equals 12, and that's by that idea of the bisect again. So for the next one, we want to find FH. So this one's a little bit trickier because FH is the entire length of the diagonal. So in order to find FH, we have to first solve for Z. So FH, I'm just going to write out what those letters are, is going to be equal to FJ plus JH. Okay, but I know that FJ and JH are congruent by the bisect. So I can actually set FJ equal to JH, and I'll get that 4Z minus 9 equals 2Z. Okay, and then what I want to do is I'm going to solve for Z. So minus 4Z on both sides. I've got negative 9 equals negative 2Z. Divide by 2. So Z equals 4.5. So don't be afraid of those decimals, that's okay. But ultimately what I want to do is I'm going to substitute those values in so I can actually solve for the entire length. So if FH equals FJ plus JH, FH equals 4Z minus 9, so I'm just substituting what I already know is FJ, plus 2Z, and then I'm going to plug in what I got for Z, so FH equals 4 times 4.5 minus 9 plus 2 times 4.5. Oops. Okay, that gives me 18 minus 9 plus 9. So ultimately, FH equals 18. So those are the two values that I wanted to solve for my parallelogram. While parallelograms are usually the types of quadrilaterals that you'll have to solve for, we can also solve for other quadrilaterals like a rhombus. So here I've got two side lengths of the rhombus. So think about what property do you need in order to solve for x. So the property that I want here is that all sides are congruent. That means that each side is equal. So if I want to solve for x, all I have to do is set 14 minus x equal to 2x plus 5, and then solve for x, just using algebra. So I'm just going to add x over. So 14 equals 3x plus 5, and then subtract 5. 9 equals 3x, and then ultimately divide by 3. X equals 3, and I'm done. If I wanted to solve for the actual length of the sides, then I can substitute that value of 3 for x and solve for the length.